Okay, once you've done that, so now we're going to calculate the total float, free float, independence float, and interference float. Okay, so that in order to see that at which activity we can do a delay. Okay, we can do a delay so that we take some relaxation. And they mean take some rest. Okay, which is not affect that the entire project. Okay, so this is what we're going to calculate in a while. Okay, now, so as we know that all the activities, you just list down all the activities A to J. Okay, activity A, B, C until J. And then we all know about that the duration of that project. Okay, for each activity, we have based on the previous result. Okay, this is a result we obtain. Okay, this result, the right bottom here, the network. So this network table, you need to translate into that the table here. Okay, so they'll give you for activity A is the 2 days, activity B is 8 days, activity C is a 10 days, and so on until activity J. So you already got that, everything's out here. Okay, now, so once you've done that, we need to fill that all the information. Okay, now first we're going to estimate that earliest finishing time, earliest starting time, earliest starting time. So you need to fill that. So earliest starting time for this case, we already know that it's a 0. Okay, then you just plug here the 0 value here, and then latest finishing time. Okay, latest finishing time. So we must look at here latest finishing time. Okay, you need to see that the head of the age of that the following task. Okay, this is what we call latest finishing time, because if you see that it's the earliest starting time, so earliest finishing time should be here. So you take this value and then substitute here 2. Okay, likewise activity B. Activity B, earliest starting time is 2, so you write the 2 here, and then latest finishing time is 16, and then write that 16 here. Okay, again for that activity C, so earliest starting time is 2. Earliest starting time is 2, and then earliest finishing time is a 12. Substitute here. Okay, now look at that activity D. The activity D, earliest starting time is 10, so write the 10 here, and then latest finishing time is 22, then your 22 will be here. Okay, and then activity E, same things. So you get earliest starting time is 12, and then your latest finishing time is 20. Okay, and then F, same things. Earliest starting time is 10. Okay, 10 here, and then your latest finishing time is 25, and then substitute here, and then so on. You substitute each everything's out of it. Okay, until that the note 7. Okay, so once you've done this, now you need to fill that your latest starting time and earliest finishing time. Okay, latest starting time and earliest finishing time. Okay, all right. So you need to, you can easily calculate based on the formulas is given from the previous slide. Okay, so these are formulas. Okay, so it's given, so you can easily calculate. So first, you already know that the latest finishing time is given L, so it's a 2. Okay, 2 minus, and then you look at the duration of the project. So this is the duration. Okay, this is the duration of the project. Okay, duration. Okay, so duration is given is a 2. Okay, so 2 minus 2, so you get that latest starting time is a 0. Okay, so you get a 0 there. Okay, now again, you take that activity B. Again, you take that the latest starting time is 16 minus 8, so you get an 8. Again, you take that the activity C, latest finishing time is a 12, and then you minus with that the duration, which is 10, you get a 6. 10, you get a 2, And then when you take that 12 minus 10 is a 2. And then again, for activity D, as we know that the latest finishing time is a 22. And then minus with the duration, which is 6 days, and you get a 16. Okay, so likewise, you get all of them. Okay, all of them. Take this, the latest finishing time, subtract with the duration, you get all the value of that latest starting time. Okay, you already get this. You already done, settle. Okay, so once you're done, now next you need to calculate that earliest finishing time. Okay, earliest finishing time. So you can use either this formula or this formula. Okay, which means you have you already calculate the latest starting time. Okay, you already calculate this, and then you subtract with the earliest starting time. Earliest starting time E, or you can take that latest finishing time minus T, yeah, earliest finishing time. Okay, either you can use either one of this formula. Okay, you'll get the same value. Okay, like we have now this information. So latest starting time. So you already obtain here. Okay, so we can subtract with the earliest starting time. So which is E. You subtract this, so you get a 0. So sorry. EF. You need to add. Sorry, you need to look at this. Earlier starting time with the duration. Earlier starting time with the duration. So you need to add with the duration time. So 0. Sorry, 0. The earlier starting time plus duration in the day. So you get a 2. Okay, you get a 2. You get this first. Likewise, earlier starting time plus 8, you get a 10. So earlier starting time is 2 plus 10 is a 12. 10 plus 6 is 16, and so on. You get all these things. Okay, so which means this formula EF. Okay, all right, now TF. Okay, now I come to TF. I just now by mistake I just look at this equation. So okay, now you're going to look for the total float. Okay, total float, since you already obtained the TEF and TLS, and you all know the information L and T. So you can check, you can use either this formula or this formula. Okay, so we know all this information. So TLS, okay, minus E. So TLS minus E, you get a 0. Or also you can do the other way around, L minus TF, which means your earliest finishing time minus your earlier finishing time. Okay, all right, so you take this value L minus 2, you get a 0. Okay, all right, now your latest starting time is 8 minus 2. Okay, 8 minus 2, you get a how much? 6, right? Okay, or the other way around, if you take that the latest finishing time minus earliest finishing time is 10, so 16 minus 10 also you get a 0. So that's why I said you can choose either one of these formula. Okay, so likewise you get all of them. Okay, so 0, 6, 0, 6, 7, 12, 6, 6, 0, 12, and 0. Okay, so you calculate, you just write down all this. But please be aware that, okay, you can see all the critical part. A, as I said earlier, right? Just now, A, C, H, J. A, C, H, J. So you see A, C, H, J. So earlier, what I said, if the critical value, the float will be 0. Okay, the float will be 0. So all the 0 value at that float, that which means you cannot relax at this critical part. Okay, you cannot relax at that or cannot rest that the critical part, which means you cannot take a day extra in order to complete the project. If you do so, what happened? the entire project completion will be affected. Okay. Now, so once you've done that, we're going to calculate that the free float. Okay, free float here. Okay, the free float formula, you need to subtract the head even slack from the total float. Okay, head even slack, which means, okay, what does it mean head even slack? So this is the head even slack. The head even slack, the difference between that L minus E. So L minus E, you get a 0. 2 minus 2, you get a 0. So this is what we call head even slack. Head even slack. Okay, so head even slack, you need to subtract from the total float. So total float is 0, is here. So you get a 0. Okay, 0 here. Okay, now again, for the case activity B, then the activity B, the total float, we obtained 6. Okay, so 6 minus, we're going to look at the total, we get that the value of that tail, head even slack. The head even slack at this point is that this head even slack. Okay, the head even slack at that activity B is 16 minus 10, which is you get a 6. So 6 minus 6, you get a 0. Okay, so 0 here. Okay, again for the activity C. Okay, the activity C, again you need to look up that activity C. What is that? The total slack, head even slack. Okay, so you get a 12, 0. Okay, so 0 minus 0. Okay, because you see the difference is 0. So L is 12 and minus with that earlier starting time is 12. That means 12 minus 12 is 0. So total float 0 minus 0, you get a 0. Okay, now activity D. The activity D is here. Okay, now again we're going to use that. So we have the total float is a 6, and then we check that the head even slack. Okay, so 22 minus 6, 16. So you got a 6. So 6 minus 6 is a 0. Okay, so you got here. And then activity E. So activity E is here. You can check that. The activity E, again, we have the total float, which is 7. Okay, and then you need to look up that the head even slack. So this is a head even slack. So it's 22 minus 16, you get a 6. But here is a 7. So 7 minus 6, you get a 1. Okay, what does it mean 1? That is which mean the free float, you can say that activity E can be delayed by 1 day without affecting that subsequent task. Which means if you take 1 day relax, 1 day delay, it will not affect that the following activities, which is activities G. It will not affect at all. That's what the mean the 1 year. Okay, so the meaning 1 year, which means when you calculate that the free float is saying that the successive event or the following event of G will not affect, okay, if you delay 1 day at that activity E. Okay, that's what it means. Okay, so next we follow that activity F. Okay, so activity F, again, the same things. We have a 12. So 25 minus 13 is a 12. So 12 minus 12 is a 0. You get here. And then, okay, now look at here. Activity G. Okay, so activity G, you have a 6 days, which means same things. So 6 days, if you delay this project, okay, if you delay the 6 days of the project at here, the activity G, it will not affect that the following activity. The other way around, you also can say, since this is the last activities, so this can be delayed any days. Okay, so this is what we need to understand the situation. So by for norms, we know that if it is 6 means that, so the 6 day 6 days delays will not affect that the successive event for the following activities. Okay, again, for activities J's like that, so you have to do the same thing. So if you see that your total float is 0, and then your head event slack is also 0. Okay, 90 minus that is 0. So that means 0 minus 0 is a 0. Okay, all right. Now same things. You can delay for 12 days. Okay, you can delay for 12 days and it will not affect that the activities. And also you can say the other way around, because since it's the last activities, it will not affect if even you delay for 12 days at the activity I. Okay, and as well the J, same things. So 27 minus 27 is 0. So you already got that total float is a 0. So 27 minus 27 is 0. So 0 minus 0 is a 0. Okay, now we just obtain that all this value. Okay, you observe that all the slack variable A, C, H, J. So A, C, H, J is all 0. See, 0, 0, 0, 0, 0, 0, and 0, 0. So automatically we know that the rest all 0 as well. Okay, as a theory, we know that all the float will be 0 for that, the critical path. Okay, all the 4 type of the float will be 0 at the critical path. Okay, so just write 0 there. Okay, just write the 0. Okay, now we're going to calculate that independent factor. Okay, we're going to calculate that independent factor. All right, so how are you going to calculate that? So as we know, the independent factor is free float minus tail even slack. So tail even slack means it's a tail. Just now we look up to the head, right? Head even slacks. Now you're going to look at the tail event. So tail event, which means you have to look for that the preceding activities, earliest starting time and latest finishing time. Okay, so you need to check on that. All right, now you see that the independent factors here, as we know that free float is a 0, and then you check that the tail even slack is a 0 minus 0 is a 0. So 0 minus 0 is a 0. Okay, so by right we automatically we know that this is a critical path, you get a 0. Now next, you look at that the activity B. Okay, activity B. So activity B, we know that this is that free float is at the 0. Okay, free float is a 0, and then look up that the tail event slack. The tail event slack 2 minus 2 is a 0. So 2 minus 0 is 0. So it means 0 minus 0 is a 0. Okay, now look at that activity D. So C is automatically is become 0 because it's a critical path. So now look at that activity D. So where's activity D? This is here. Okay, so activity D, as we know that the free float is a 0. Okay, free float is a 0. Now we're going to look at that is a tail event slack. Okay, tail event slack. Wait, I cannot fix this. Okay, tail event slack is a 16 minus 10 is a 6. So as we know that 0 minus 6 is a minus 6. Okay, please remember that if we get a minus value for interference slack, you need to assume that is a 0. Okay, it's not, it doesn't make any difference. You need to assume that as a 0. Okay, all right, now next activity E. Okay, so activity E. So again, so as we know that the tail event slack is at 12 minus 12 is 0. So we have a 1. So 1 minus 0 is a 1. Okay, what does it mean? So this means that you can say that activity E can be delayed by 1 day without affecting the preceding activity, which means if you take 1 day rest here, okay, 1 day rest here in the activity E, it will not affect the preceding activity, which is activity C. Okay, it will not give any effect to that the activity. Okay, so that means it's a permitted, so you can take that the independent float saying that it will not affect that the preceding activity of C if you take 1 day delay. Okay, now next your activity F. Okay, again activity F, if you do so you will get tail events as 0 minus 16 minus 10 is a 6, so 0 minus 6 you get you assume that as a 0. Okay, and then activity G, same things. All right, you can see that you get a 0 value. Okay, if you look up that the 6 minus the tail event slide is a 6 as well, so 6 minus 6 is a 0, so you just write the 0, and then your I will be 0 as well. Okay, so I is a 0 as well. Okay, now once you've done this, okay, so now moving on that interference float. Okay, the interference float, the last part. So the formula is the interference float is straightforward. Okay, it's a total float minus that the free float. Okay, so total float, okay, minus with that the free float, then you will get that the interference float. So again is straightforward, 0. So 6 minus 0 is a 6, and then 6 minus 0 is as well is a 6, and then this is 7 minus 1 is as well 6. Okay, and then is a 12 minus 0 is a 12, and then 0 minus 0 is a 0. Okay, and then 12 minus 12 is 0. Okay, so you just write that. I think I already write in the. Okay, okay, what does it mean if you got a 6 means? It means that if the 6 days for the activity B indicate is an allowable delay for that specific activity without affecting that the project overall timeline. Okay, say if you even take 1 day extra, it will affect that the entire project completion. Okay, so that means this 6 days is the maximum allowable time. Okay, maximum allowable time for that the entire project, which is not affecting that the entire project completion time. Okay, so this 6 again, so you can take that the activity 6, the interference is 6, and for the F is 12, and then the G is 0. Okay, as well as the I will be the 0. Okay, so basically this all you need to know that how we need to calculate, okay, the 4 type of the floats, okay, in the critical path method in order to identify that the project relaxation, okay, where the project need to be can be delayed, okay, and which sections to be not, okay, you should not to delay. So this roughly the idea will help us in order to predict that the project completions overall.